Alright, let's look at the homework 11.5, problem number 5. Alright, so let's look at this alternating series. Alright, so we can see that the Bn is just this part without negative 1 to the n. So this is our Bn. Alright, to apply alternating series test, we have to check two things. First one is Bn is actually decreasing. So we have that. Alright, so let's check that. The easiest way to do to show that would be look at it as a function and look at its derivative and to see if it's negative. So I'm going to let f of n is equal to n over square root of n cubed plus 8. Alright, so let's look at its derivative. So f prime of n, so we're taking a derivative with respect to n using quotient rule. Right? Square the bottom denominator, so we have n cubed plus 8. Right? Derivative of n is 1 times the denominator, so it's a square root of n cubed plus 8 minus numerator is n times the derivative of the denominator. So square root is 1/2 power, so put 1/2 in front. Keep the same inside function, so n cubed plus 8. Subtract 1 from the power, so negative 1/2. Then multiply by derivative inside, which is 3n squared. Alright, so to get rid of a fraction inside a fraction, I'm going to multiply top and bottom by, actually there's 2 there too, so I'm going to multiply by 2 square root of n cubed plus 8. So you have a 2 square root of n cubed plus 8. Alright, and this is going to be equal to, alright, so denominator, you're going to have 2, oops, right, and then you have n cubed plus 8, quantity raised it to the 1 plus 1/2, so it's going to be a 3/2 power. Alright, then we're going to distribute that to, so square root is gone, so you have a 2 n cubed plus 16. So all I did was distribute this guy to first term, right? And then we distribute this guy to the second term, and you can see that 1/2 is canceled out because of 2 here, and this is the reciprocal of that guy, so these two guys cancel out. Alright, so what's left is just going to be negative 3n cubed. Alright, so you have a negative 3n cubed. Alright, so this is going to give us, so you have a 16 minus n cubed. Right? So then this is going to be over 2 times n cubed plus 8 to the 3/2 power. Alright, so denominator in this case looks like here, this denominator right here. Since n is a natural number, so it's this is positive, plus 8 positive, everything is positive. So we know that the denominator is positive there. All right. So the numerator, in the beginning actually it's positive. So if you put the 2, so 16 minus 2 cubed 8, so it's actually positive. But starting from 3, so n equals 3, so 16 minus 27, so that's going to be negative. So we know that this is going to be definitely negative, starting from n equals 3, so greater than equal to 3. All right, so it's actually negative starting at n equals 3. So this implies that we have decreasing. Right, so maybe I should say one more step. So f of x, f of n is decreasing for n is greater than or equal to 3, right? So which implies that Bn is definitely decreasing for n is greater than or equal to 3, right? So we checked this guy here. So the first condition is satisfied. All right, so let's look at the second condition. All right, so number 2, right, we have to show that limit, or we have to check, actually, we don't know that. So as n approaches infinity is equal to 0. So it's a question mark. All right, so let's do that. So you have a limit as n approaches infinity of n over square root of n cubed plus 8. All right, then I would probably maybe divide top and bottom by n. Right, then what you get is going to be, all right, so this is going to give us a limit as n approaches infinity. All right, so the numerator becomes nice and simple and cancel out. So if you put 1 over n inside that square root, it's going to become 1 over n squared. So you have a square root of n cubed divided by n squared would be n. So you have 8 divided by n squared. Right? And as n goes to infinity, you can see that this guy approaches 0. Right? So which means that this is going to give us, right, let's see, this is going to be, I'll just go here. All right, as n approaches infinity, the denominator goes to infinity. So 1 divided by, maybe I'll write that 1 over infinity would be 0. All right, so this guy checks out. All right, so since it satisfies both hypotheses of alternating series test, we say therefore, right, the series converges by alternating series test. All right, let's check the answer. All right, so actually it's already here. So submit for testing. All right, looks like we got this one correctly. All right, that's it. I hope that this was clear.